Hi, I'm Nick at the EEWeb Tech Lab. Today I have ROHM's BD7F100 and BD7F200 optocoupler-less isolated flyback converters. That's right, these flyback converters are optocoupler-less, meaning they have no optical feedback. Traditional flyback converters have either an optocoupler or a dedicated winding feedback circuit for obtaining a stable output voltage. However, these flyback converters from ROHM have neither, resulting in a drastic reduction in part count, which allows for a smaller sized and high reliable isolated DC power supply. These converters have an output load compensation feature that corrects for voltage sag during load increases. Also, the output voltage can be set by two external resistors and the transformer turns ratio. So ROHM has provided us with this well laid out and easy to use evaluation board. It accepts 24 volts on the input and produces 5 volts on the output. The output current range is from 13.8 milliamps up to 800 milliamps for a maximum power of 4 watts. So let's take a closer look at this board. This is the VN connector. This is the BD7F100 IC. R4 and R5 are the two resistors for setting the output voltage. C4 and R3 are the two parts used for the load compensation feature. This is the transformer, and this is the V-out connector. So let me give you an overview of the setup I have here. This is a 24 volt power supply connected to the VN connector. This is the DMM, it's connected to the input voltage. This is an electronic load, it's connected to the V-out connector. And this load will cycle between 50 milliamps and 800 milliamps. 50 milliamps would represent a light load, and 800 milliamps would represent a heavy load. And then finally, the oscilloscope is connected to the V-out. So I'm going to be performing two demonstrations today. The first is with C4 not being populated and R3 being populated with a 0 ohm resistor. In this configuration, the load compensation function is disabled. We'll look at the output variation using the load cycling between 50 milliamps and 800 milliamps. So let's get started. Turn on the power supply and the DMM. I'm going to set the power supply to 24 volts and a current limit of 1 amp and enable it. So as you can see, 24 volts is applied to the input voltage connector. And now I'm going to turn on the electronic load. So 50 milliamps corresponds to 5.06 volts, and now 800 milliamps corresponds to 4.92 volts. Again, 50 milliamps, 5.06 volts, and 800 milliamps, 4.92 volts. So about 140 millivolt variation when the load compensation is not being used. So I'm going to take this board, I'm going to modify it, and then I'll come back for the second demonstration. So I'm back with a modified board, and what I've done is installed an appropriate resistor and capacitor at R3 and C4 to illustrate how the load compensation function works. So again, I'm going to use the electronic load to cycle between 50 milliamps and 800 milliamps, and we'll look at the voltage variation on the scope. So 50 milliamps and 5.11 volts, and 800 milliamps and 5.12 volts. So again, 50 milliamps, 5.11, and 800 milliamps, 5.12. So the output voltage variation is about 10 millivolts, which is much better than the previous 140 millivolt variation. So the point is, by simply adding a single resistor and capacitor to the board, the load regulation may be drastically improved. The BD7F100 is a 1 amp part, which has a supply voltage range from 3 volts to 40 volts. The BD7F200 is a 2 amp part, which has a supply voltage range from 8 volts to 40 volts. These two parts offer features including a fixed 400 kHz switching frequency, a low output ripple voltage, a highly efficient light load mode using PFM operation, and overcurrent protection. Industrial equipment requiring isolated power supplies are ideal applications for these optocoupler DC to DC power converters. And as always, ROHM guarantees long-term support for these devices, which is very important for safety and EMI testing. For more information, visit rohm.com.